In this question, we want to find the perimeter of the shaded region. So to do that, we need to divide our kite shape AOBT into two triangles. So we divide it along this line here. We divide it along this line here. Right. Now let's bear in mind that R is a radius and AT is a tangent to the circle. So the two will meet at 90 degrees. There is 90 degrees where the radius meets the tangent. Right, so this angle here is theta. Right, since we have divided 2 theta by 2, that angle there is theta. And this side here will be the opposite. And this side here is the adjacent. Right, so we have got opposite and adjacent, and we have theta there, and they are linked by the trig ratio tan. So tan theta is equal to opposite over adjacent. Right. Putting the actual letters there, our opposite is the distance AT. Our adjacent is R. Right, so in other words, AT equals R tan theta. AT equals R tan theta. Right, and we have two distances equal to AT. There is AT and there is BT. Those two, each one of them is equal to R tan theta. So the distance AT plus BT becomes AT plus BT becomes 2R tan theta. Right, so we have 2R tan theta, and for us to find the whole perimeter, we are only left with adding AO and we're only left with adding OB and OA to what we already have here. So our perimeter P is equal to OA, which is R, plus OB, which is another R. So we have 2R. We have 2R plus AT plus AT plus BT, which is this thing here. So we have 2R plus 2R tan theta. That's our perimeter there. 2R plus 2R tan theta. For this part of the question, we want to find the shaded area. What I've drawn there is only half of the area that is required, right? But how will we get that half? We have a triangle and a sector, right? So to get the shaded area in this particular diagram, we have to find the area of the triangle and subtract from it the area of the sector. Right, in this question, we want to find the area of the shaded region. What I've drawn there is half of the area required. What we're going to do is to find the area of the triangle and subtract from it the area of the sector. So the area of the triangle is given by the formula half base times height. Since it's a right angle triangle, all we have to do is to say R times R tan theta, then half of that, which gives us half R squared tan theta. Right, so this is the area of the triangle, and we then subtract the area of the sector from that area. So the area of the sector is given by half R squared theta. So we subtract half R squared theta. Right. Now, half r squared is common. We can factor it out, and we have half r squared tan theta minus theta. Right. So this is the shaded area in this diagram that I've drawn. Right. What we need to do next is to multiply this by 2, since there is the other half that we need to consider. So for us to cater for this other half, all we need to do is to multiply this equation that we already have. We need to multiply it by 2. Right, so finally we get r squared tan theta minus theta. R squared tan theta minus theta. Right, that's the area that is required here. So we are given the value of r there and the value of theta there. So all we do is to substitute. So substituting will give us r squared. In this case, r is 5. So 5 squared. Then we have tan theta. We have tan 1.2 minus 1.2. Right. Then we punch this into our calculators and we get 34.3. Right, we are not given any units, so it's 34.3 units squared, like that.